You know, when you see a dog, your brain just knows. You see the image, you think the word dog. It happens in an instant, totally effortless. But for an AI, well, connecting that world of pixels to the world of words has been one of the biggest challenges out there. So how do you actually teach a machine that can see to also understand what it's seeing?
So today, that's the journey we're going on. We're going to start with the problem, this idea of a divided AI world. Then we'll look at the breakthrough solution, this kind of great AI matchmaker. We'll peek under the hood of the model that actually does all the work, put it to the test, and then see why this thing is, no joke, already changing everything around us.
All right, let's dive right in. To really get why this breakthrough is such a big deal, we got to go back and look at how things used to be.
See, until just a few years ago, AI models were total specialists. They each lived in their own little bubble. You had your computer vision models over here that were geniuses with images, and your language models over there that were wizards with text. But the problem? They couldn't talk to each other.
It was a classic case of two experts speaking completely different languages. An AI that could see couldn't read, and an AI that could read couldn't see. The image model could break down a picture of a cat into all its pixels and shapes, but it had no clue what the word CAT meant. And the language model? It knew what cat meant in a sentence, but it had no mental picture to go with it. They were totally separate, unable to connect the dots.
So how in the world do you bridge that gap? Well, the solution turned out to be this incredibly clever and powerful idea. The whole goal shifted to something called multimodal learning. The idea is, let's stop trying to have two separate specialists. Let's teach a single AI to build one unified picture of the world by combining its senses, just like we do.
And the strategy they came up with is actually pretty easy to wrap your head around. It's called contrastive learning. And you can really just think of it as teaching an AI to play a gigantic world-sized matching game.
Here's how the game works. You give the model an image, let's say a dog on a beach, and you give it the correct description. You tell the model, hey, these two things mean the same thing, pull them closer. Then you show it that same picture of the dog, but this time with a totally wrong description, like a bicycle in the mountains. And you tell it, nope, these are not a match. Push their meanings as far apart as you can. You do this billions and billions of times with images and text from all over the internet, and slowly but surely, the model starts to build its own internal map of meaning, where similar ideas all group together.
So let's see how this actually gets built inside a real model that made all this famous. We're talking about CLIP, which was developed by OpenAI.
Okay, so the CLIP model has two main parts. First up, you've got the image encoder. Think of this as its vision brain. It uses a really powerful tool called a vision transformer to look at an image, figure out all the important patterns, and then boil down its visual essence into a simple list of numbers, what we call a vector.
And then, part two is the text encoder. Yep, you guessed it, the language brain. It takes a phrase like a photo of a dog and does the exact same thing. It uses a text transformer to understand the meaning of the words and turns that meaning into its own unique vector.
Now here's the absolute key. You've got two different brains creating two different numerical fingerprints, or vectors. The entire goal of that massive matching game we talked about is to train these two brains so that their vectors are perfectly aligned, to get them to speak the same universal mathematical language.
And this is the beautiful result you get. You end up creating this unified map, a shared space of meaning. And in this space, the vector for the picture of a puppy ends up right next to the vector for the words, a cute puppy. They're finally linked. They're in the same neighborhood.
Okay, so this all sounds amazing in theory. But now for the really fun part. Does it actually work when you put it on the spot?
So, to find out, we can give the model a little pop quiz. We show it 4 completely different images: a dog, a cat, a bird, and a car. Then we give it 4 text descriptions, like a photo of a dog. The test is super simple. Can it figure out which text goes with which image, with 0 special training for this specific task?
So let's look at the results. This table shows the similarity score for every possible combination. The higher the number, the more confident the AI is that they're a match. And would you look at that? If you just look down the diagonal, you see the highest score in every single row. The text, a photo of a dog, gets a 27.3 with the dog image, way higher than any other image. And it's the same story for the cat, the bird, and the car. It's a perfect set of matches.
So the verdict is in. It passed with flying colors, 100%. This is huge because it proves the model can take what it's learned and apply it to a totally new task it has never, ever seen before.
Okay, this is a seriously cool tech demo.
But why should you care? What does this actually mean for you in your day-to-day life?
Well, this incredible ability has a name. It's called zero-shot learning. And it is a fundamental game changer for AI. Because Clip learned from this giant, messy, diverse chunk of the internet. It didn't just memorize a bunch of facts. It actually learned a flexible, general-purpose understanding of concepts. An understanding it can use to tackle countless new tasks it was never explicitly taught how to do.
And this isn't science fiction. This tech is already baked into tools many of us have heard of or even use every single day. When you search for an image using words on a site like Pinterest or Bing, this is the magic behind it. It's also the critical judge that tells text-to-image models like DALL-E or Midjourney if the picture they're making is actually matching your prompt. It's used to automatically tag photos, and it's even helping robots understand simple commands like, "Hey, go get me the blue cup from the table."
At the end of the day, this isn't just about one cool model. Multimodal AIs like Clip are a massive milestone. They really are a foundational piece for creating smarter, more integrated AI that can perceive and reason about the world in a way that feels much more, well, human.
And that leaves us with this one final, fascinating question. We've finally bridged the gap between vision and language. Now that an AI can truly connect what it sees with what it reads, what on earth is the next human-like skill it's going to learn? This convergence has kicked open a door to a whole new frontier of what's possible.